Hello students, here is the solution to problems 13 and 14. So for problem 13, determine the horizontal deflection at B, cross-sectional areas in mm square are enclosed with parentheses. E is 200 gigapascals. So I'll apply Casigliano's second theorem here, but before that, observe that the lengths of the triangle are 3, 4, 5, which are sides of a right triangle. So perpendicular at this vertex B here, so that's 90 degrees. So if I call this theta, drop a vertical line, so this is also theta. We have similar triangles. So from the figure, y as to hypotenuse for this right triangle, opposite of theta as to hypotenuse. So y as to 3 hypotenuse equals, for this big triangle, opposite of theta is 4 and hypotenuse is 5. So 4 over 5. That's why y is 2.4 meters. Then x as to hypotenuse, adjacent of theta as to hypotenuse, equals, for this triangle, adjacent of theta is y, which is 2.4, and the hypotenuse is 4. Or the other way around, the easier one is x is square root of 3 square minus y square, because we already solved for y 2.4, so it is 1.8 meters. So if this is 1.8, 5 meters minus 1.8 is 3.2 meters. Therefore, the slope of AB, x is 1.8 divided by zero point 0.6, so it is reduced to 3. 2.4y divided by zero point 0.6, so it is reduced to 4. That's why you have 345, the slope of AB. Then for the slope of BC, y is 2.4 divided by zero point 0.8, so 3. 3.2 divided by zero point 0.8 is 4, so we have 3, 4, 5. So we sum up moments about A to solve for we sum up moment about C to solve for AY. So AY times 5 meters plus P times 75 times Y, which is 2.4, then equals 120 times 3.2. Simplifying, AY is negative 0.48P plus 40.8. Likewise, summation moment about C equals 0. So R sub C times 5 then equals 120 times x, 120 times 1.8 plus quantity p plus 75 times y, which is 2.4. So R sub c is 4.48p plus 79.20. Then at summation forces x, of course, this is p plus 75 leftward opposite to this. Beginning at A, summation forces y equals 0. Vertical component of SAB is SAB times 4 over 5, which is this. Then plus AY, which is negative 0.48p plus 40.8 equals 0. So SAB therefore is 0.6p minus 51. Then summation forces x, SAC, plus the horizontal component of AB, so SAC plus SAB, which is 0.6p minus 51, times 3 fifths, horizontal component, equals P plus 75. Simplifying, SAC is 0.64p plus 105.6. Then we proceed to joint C. Summation forces vertical equals 0. Vertical component of SBC is SBC times 3 fifths. Summation forces y. Then plus R sub C, which is 0.48p plus 79.2 equals 0. Simplifying, SBC is negative 0.8p minus 132. So we already found all these three members. So all you have to do is check equilibrium. Summation forces x at C, leftward positive. So SAC, which is 0.64p plus 105.6, plus the horizontal component of SBC, which is quantity negative 0.8p minus 132 times 4 fifths. So it is indeed 0. Then we check equilibrium at B, summation forces X, P plus 75, then plus SBC, which is quantity negative 0.8 P minus 132 times horizontal component, so times 4/5, then minus SAB, horizontal component of SAB, so minus quantity SAB is 0.6 P minus 51, and multiplied by 3/5 to obtain its horizontal component. And if you add P's, it's 0. If you add the constant, it's 0. So checks. Lastly, summation versus Y. So negative 120. Then minus vertical component of SBC is minus SBC times 3/5 minus the vertical component of AB. So minus AB SAB 0.6P minus 51, then times 4/5, that's the vertical component. So adding the p's, adding the constant, it's also 0. So it means that all our calculations are correct. The system is in equilibrium. So we tabulate. We have three members only, A, B, AC, and BC. Remember that P is just invented, so it is 0. So SAB 0.6 P minus 51. The partial derivative with respect to P is 0.6. The length of AB is 3. Then getting the product. So prior to product, we set P0, negative 51 times 0.6 times 3 is negative 91.8. Then SAC 0.64P plus 105.6. The derivative with respect to P is 0.64. The length of AC is 5 meters. Then set P0, 105.6 times 0.64 times 5 is 337.92. Then finally, for BC, negative 0.8 P minus 132. Derivative is negative 0.8. Length is 4. So set P0, negative 132 times negative 0.8 times 4 is 422.4. Take note that these members have different areas. So summation of S, partial of S, with respect to P times length over AE is equal to the horizontal deflection at B. And it should be multiplied by 1000 square because this is in kilonewton meter to make it Newton mm, divided by area, which is in mm square, E in megapascals, Newton per mm square, or 200,000. So we factor out 1000 square and 200,000 because that is common, and we only divide these values by the area. So this is the calculation. Delta BH is negative 91.8. This is member AB, and the area of AB is 1000, so we divide by 1000. This is the common factor to make the units mm, 1000 square over E, 200,000 megapascals. Then for AC, 337.92, the area of AC is 1200. Then for BC, 422.4, the area is 1500. So calculating, delta BH is 2.357 mm. Since it is positive, it is rightward. So that's it for problem 13. For problem 14, by moment distribution method, determine the reactions at A and D. So A and D only. Some of you were not following instructions. You still compute RC. I'm not mentioning reaction at C there. So first, let's have the stiffness. Uh, we expect moments at all joints. So EI over 4 EI is treated constant, so 1 over L. So 1 over 8, K here is 1 over 6, K here is 1 over 9. The distribution factor for fixed end, 0. The distribution factor for D is also 0, so 0. Distribution factor BA is 1 over 8 divided by 1 over 8 plus 1 over 6, so it is taken negative 3 over 7. So therefore, for BC, negative 4 over 7. Distribution factor CB is 1/6 divided by quantity 1/6 plus 1 over 9. It is 2/5, 3/5 rather. So it is treated negative, negative 0.6. So CD negative 0.4. And distribution factor at D0. Next, we compute fixed moment at A, AB, left A, so negative W, negative 15, L square, 8 square over 12, so negative 80. So it is positive 80 on the other end by symmetry. For BC, symmetrical also, negative at B, negative 30 times 3 square over 6 square, so negative 22.5 at C, positive 22.5. Then fixed moment CDs at C, negative W 36, L square 9 square over 30, so negative 97.2. I'm not showing it here. Then at D, positive 36, 9 square over 20, 145.8. So negative 80 times 0, so don't mind here, it is always 0 when we distribute. So here at joint B, quantity 80 minus 22.5 times negative 3 over 7 is negative 24.64. Replace 3 by 4, it is negative 32.86 lakh. Here, quantity 22.5 minus 97.2 times negative 0.6, 44.82 lakh. Replace zero point 0.6 by zero point 0.4, 29.88 lakh. Of course, 145.8 times 0 is 0. I'm not showing the zeros anymore. So with this, we'll just receive carryover from this end. It cannot, the distribution factor is always is 0, so it cannot uh, distribute moments, unbalanced moments. Same is true here. So next step is carry over. Half of negative 24.64 is negative 12.32. No moment to be carried over there because the distribution factor is 0. Remember, the distributed moment is 0. So half of 44.82 is 22.41. We encircle that because that's the carried over. That's the new unbalanced moment at joint B. Half of negative 32.86 is negative 16.43. So it's also enclosed. Of course, half of nothing is nothing. Then half of 29.88, 14.94. So we again distribute this moment 22.41 times negative 4 over 7, negative 12.81 lakh. Then replace 4 by 3, it's negative 9.6 lakh. Then at C, negative 16.43 times negative 0.6, so 9.86 lakh. Replace zero point 0.6 by zero point 0.4, it's 6.57, so lakh. Then no moment here to be distributed. Next is carry over. Half of negative 9.6 is negative 4.8. Half of 9.86 is 4.93. Half of negative 12.81, negative 6.4. Then half of 2.56 is 1.28. No moment shall be carried over here. The distribution factor is 0. Then, and so on and so forth until the distributed moment is negligible. That's the time we lock it finally. Like here, negligible, we stop. Then here also. So adding these values here, there's no need to explain in more details about how these moments are generated. It is expected of you that you know it, because if you do not until now, uh, that's your problem. So adding, we have negative 98.73, adding these columns of 42.56, this column here, negative 42.56, so that shows that the tabulation is correct. So here, adding 57.34, adding these moments, negative 57.34, so correct. And adding this 165.72. So that means uh, these are the reactions. So I assume AX is leftward. Moment AB is negative, so it is counterclockwise here. Moment BA is positive 42.56, so it is clockwise as shown. Then considering AB, summation moment B equals 0, AX times 8, that's the equation there, then plus 42.56 is equal to 98.73 plus moment of the load 15 times 8 times 4. So from there, we can solve AX 67.021 positive. So it is correct leftward. So leftward. Then for BC, the reaction at B just to the right is when transmitted to this column is AY actually. Summation moment C equals 0. By the way, moment uh, BC is negative, so counterclockwise. Moment CB is positive, so clockwise. Moment CD is negative, so counterclockwise. DC positive, 165.72, so clockwise. So again, considering BC, summation moment C equals 0, RB right times 6 plus 57.34 equals 42.56 plus 30 times 3. So RB right is 12.537. As I said, it is also AY. So AY is 12.537 kilonewtons upward. The moment at A is negative 98.73. Then at D, considering CD, summation moment about C equals 0, so dy times 6, x first, considering the entire system, summation versus x. So we have 15 times 8 rightward, then equals AX 67.021 plus dx, assuming dx is also leftward. So dx is 52.979 kilonewtons leftward, really. Then, considering CD, summation moment C equals 0, dy times 9, then plus 57.34 equals 165.72 plus the moment of this triangular load, 1/2 of 9 times 36, moment arm 2/3 of 9, which is 6. Solving for dy is 120.042 kilonewtons upward. Remember that the moment at D is moment D something, not moment DC. If moment DC is positive, then moment D something or moment at D is negative. So we just make it negative of 165.72. So that's it for this video.